Hey Samuel, so I think I've loaded all of the ones that you sent me from the notes. If I've missed one, let me know. But this is the one that you and I went over already together, and it looks exactly the same as what we did. So hopefully that will make more sense now that we've gone through it and explained it. Let's have a look at the next one. Okay, so let's take a look at this one, and this one's kind of neat because if you take the first derivative, you get 4x cubed, and if you set it equal to 0, you get 0 for x, and y is also 0, and so you have the origin as a possible critical point, okay? So possible max or min, it is a critical point, we just don't know what's happening there. And so if we investigate further and we test this point, if we try it in the second derivative, we're going to also get 0. So it doesn't tell us whether it's a max or a min because we have to get a negative or a positive to know that. So if we go to the chart method and we try it out, then we're going to try a number before 0 and one after 0, and we can clearly see that the slope is changing from negative and then going to 0 and then to positive at this value. And so we're going to then declare that 0, 0 is a min. Okay, and the graph looks sort of like that, but when you have x to the 4, it's actually more square on the bottom. Oops, and it kind of does that, and so you have your minimum point here, but it's got more of a square bottom to the u instead of more of a like a round bottom. And then the second question that you have on this page, sorry, let's have a look. Oh, okay. So we have x times e to the negative absolute value of x, and so we've broken this down into a piecewise function because it depends on what values of x we have, what's going to happen here. So it equals e to the negative x if x is positive. That just means that the absolute value signs weren't necessary because it was already positive. And if x is negative, then it's going to equal e to the negative x, like that, which makes it e to the positive x. And so we have sort of a piecewise function. It's two different functions that define this function depending on which side of the y-axis you're on. And so if we find our derivative of both functions, which we did here, and we set them equal to 0, we should be able to see if there's any max or min points. So for the first function, I think there's more on another page here maybe. Let me check and see if it's on the next page. Okay, so this slide is just explaining how max and min works, and you and I talked about it a little bit. Here we have a negative slope, and then a 0 slope because it would be a horizontal line, and then we have a positive slope, okay? So that's when your first derivative goes from negative to 0 to positive, because the first derivative is the slope. So in the second case, here we have a max, and it's going to be the opposite. We have a positive slope first, and then we have a negative slope coming back down. So that's why it's positive to 0 to negative. And then what happens is if it's positive to positive, like all of our slopes here, all of our tangent lines have positive slopes, but there is a critical point. This is a critical point right here. So it's not changing slope, it's changing concavity. So this is concave down, this is concave up, and that's what's happening at that point 0, 0. And it went from positive to positive, but that point turned up in your second derivative as a critical point. And the same thing here, where this has a negative slope for its tangent, and even after it goes through that critical point, it still has a negative slope. So if it doesn't change slope, it's not a max or min, it's a POI, a point of inflection. And you find those in your first derivative sometimes, but you always find them in your second derivative, okay? So for example, they're doing down here, the first derivative is 3x squared, and they set it equal to 0, so x equals 0. So in our chart, let's make this a wee bit bigger and have a look at it. In our chart, what we're going to do is start with 0 in the middle, and then we want something less than 0 here and greater than 0 here. So we could try like -1 and 1. Just choose numbers that are going to be really easy to work out, okay? If I put -1 in, I get positive. If I put +1 in, I get positive. So there's obviously no max and min here. It's got to be what we call a POI. It's concave up, goes through that critical point, and then it's still concave up. And so this is like an example of that would be like where it goes up like that, and there's a point right in the middle. Sorry, nope, that's not the one. An example of that would be the x cubed function that goes up like a snake. It crosses through 0, 0, and then it continues to go up like that. And so every point where we try to draw a tangent line, it's going to have a positive slope, right? But there is a change in this graph because it's going from concave down to concave up. Like the cup is holding something in concave up and the cup is spilling something in concave down. And so that's the change in the graph that this function is trying to tell us is happening at 0, 0. And so we know that because if it goes positive 0 and then positive again, it's not a max, it's not a min, it's got to be one of these special points. Okay, here's the page where they actually took the function and they got 0 and then they tested it. Trying to remember what we had. Oh, so when f prime was 0, we got plus and minus 1. I think that this goes with that last example. Okay, sorry this is a bit messy, but this is, if we set these functions equal to 0, which were the ones that we got from our derivatives, then the only way that they can be equal to 0 is if what's in the bracket equals 0, because e to the x never will be. And so in the first case, x has to equal 1, and in the second case, x has to equal -1 for that to happen. Okay. And so here we are in the chart, and we're testing -1 and 1. And so we're testing values before -1. Then we're testing a value in between -1 and 1, like maybe 0 or something like that. Then we're testing at +1. Then we're testing at higher than 1. And we can see that it's going negative, 0, positive, 0, negative. So that means downhill, 0, sorry. Okay. Downhill, 0, uphill, 0, downhill. And so that's what our graph has to look like according to what the chart is saying. And then that's what we ended up with here for our graph, because we know that 0, 0 is a point where something's happening in this graph, and it should come out in the second derivative as what we call a point of inflection, okay? And so what a point of inflection is you notice how this graph is like concave up on its way up to that point, and then concave down, like curved downwards like that after that point. So that point right in the middle is what we call a point of inflection, and that happens when your double derivative is equal to 0. And so that's what's happening here. The concavity is changing, and I'm not sure that you even got to that topic yet, but that's what's going on there at the point 0, 0, and that's why it's marked on the graph.